Hi everyone, we're about to get started with Chapter 6, the normal distribution. So just want to check in with you here. I am off campus. I have set up my office here. You see my computer, got my stuff. It's my son's stroller. Set up a little table here, a little folding table here on my front porch. A little cool this morning, so I got the beanie on. We got our freezer right back here since we're all on lockdown. Not supposed to leave your home much these days. So we're all set here, and I'm feeling cozy here in my new office. So I hope you guys are doing well, being at home and all that. Anyway, let's get into chapter 6. So if you haven't already, go back and read the first page of the chapter 6 lecture on the normal distribution. And I give some points, or 7 points kind of some features, and I give you the shape of the normal distribution. So I'm not going to refer to that, maybe except for one item. I'm going to pick it up where it starts with the z-score, and those are the nature of our first couple of practice problems. And you see the same shape there at the top of page 2 of the lecture, and it looks pretty much like what I've drawn here. So the idea behind the normal distribution, you would think, what are the chances that we have a continuous, random variable and ends up giving this perfectly symmetrical, very nicely shaped normal distribution. And it turns out, actually, it's much more likely that we get the normal distribution than anything else, the truth is. So, I listed back toward the top of the lecture just all the applications: business, economics, education, chemistry, medicine, psychology, real estate. Those are, just a handful. Click on that link that I gave as well and look at some other real life examples on that website. Probably take you about a minute to scroll through and just look at all 9 of those. The normal distribution happens, so useful, happens a ton. We're going to spend a lot of time studying this. Truth is, it's almost the rest of the course is based on the normal distribution. We're going to really get in depth of it, spend several chapters on it, looking at it from different perspectives and in different applications. So really the big thing is that the mean is at the center, and you've seen I've written that here. So the average value, turns out it's the median and the mode as well, is right there at the middle, but we're really going to think of it as the average, the mean. We're going to call the mean z equals 0. So what's up with this z? Z tells you how many standard deviations you are from the middle. So if you are exactly 1 standard deviation away, we're going to call that z equals 1. Or maybe if you're 1 standard deviation below, we call that z equals -1. If you're 2 standard deviations up, we're going to call that z equals 2. Or if you're 2 down, -2, and we could go 3 up or 3 down. You could go more than that. This thing goes on forever. But we really spend most of our efforts at 1, 2, 3, -1, -2, -3, and you can certainly pass beyond that. But it turns out if you're even 3 standard deviations away, say on the upper side, this thing, the probability is so small to get that far above the average that we really don't talk about it all that much. So kind of the main idea here, and we're really making sense of what a standard deviation is, and now it's really going to come into our thinking. If I move 1 standard deviation, then I'm that far away. Every normal distribution, now this is what's so useful about it. If I move 1 standard deviation up, I've always covered the same amount of spread. That would be the same area, the same probability for any normal distribution if I move up one standard deviation. No matter what the mean of the data is, whatever I calculate the standard deviation to be, if I move up by one, that probability is always the same for every normal distribution. And if I move up another one, this probability, every normal distribution, that little chunk right there, although the curve might look a little bit different, the amount, the percentage, the probability of data between 1 and 2 is always the same for every type of data that would fit a normal distribution once you consider the mean and what their standard deviations are. It's really, really cool. Okay, that might not make a lot of sense yet until we actually start to see some numbers. So we're going to get into practice number 1 right now, and we'll kind of make these drawings and sort of highlight what's happening when we actually get some numbers to work with. Okay, so practice number 1, we've got this formula for the z-score. X represents the data value in question. Mu is the average, sigma is the standard deviation. And so if we look at practice problem number 1, all we're doing is calculate the z-score. Let's just get used to this formula. And we start off with x equals 40, the mean is 34, the standard deviation is 8. So we're going to plug those in. Our x value, our mean, our standard deviation, it's just that simple. Our z-score here is 0.75. Okay, but what does that mean? Z equals 0.75. So here's my sketch. I've got that same sketch of the normal distribution curve. It always looks just like that. Right at the middle, I've put the average, in this example, 34. The value in question is 40. And you might ask, well, I've also drawn 42. Where does the 42 come in? What's significant about that? Well, in this case, that would be one standard deviation, right? Plus 8. That's one standard deviation above the mean. So if we called this z equals 0, this 42 would be z equals 1. One standard deviation up. And the value in question is 40. So we're like, what's the z-score there? How many standard deviations is 40? Well, it's not quite 1. It's less than that. And that's what our formula calculated for us. It's 0.75 of a standard deviation above that mean of 34. That's the idea. Okay, let's go on to part B. And okay, I've kind of gotten it started for us already. It says x equals 123 with a mean of 150 and a standard deviation of 15. So I've plugged in my x, my mean, my standard deviation. You can kind of see my drawing there already. Plugging those in. This time I got a negative z-score, negative 1.8. So, all right, yeah, we know z's can be negative. That just means you're counting to the left. And here's my drawing. So I've marked just the important aspects. So they told me right there at the middle, the mean is 150. And you see I've counted 2 standard deviations, 15, subtracting 15 again. So this would be z equals 0, z equals negative 1, z equals negative 2. The value in question is 123. You're like, okay, well, it's quite a bit past 1 standard deviation, but not all the way to 2 standard deviations below. And so exactly how many is that? And well, that's what we calculated. It's negative 1.8 standard deviations below that mean of 150. Like, okay, we're really talking about standard deviation a lot all of a sudden. How many standard deviations did we count? And it turns out this is everything with the normal distribution. How far did you move from the middle? We always think of as how many standard deviations is that, because that tells us how much data we've covered between that middle point. How big was that? Oh, kind of knocked my camera there. How far did we jump as far as, that probability, that area? Okay. Well, that's practice problem number 1. Let's go on. Let's do practice problem number 2. And I think that will do it for this first video. We start to see some of the usefulness here in practice number 2. I can slide my paper up a little bit. Don't want to give too much away. So it says test scores follow a normal distribution. Yeah, that's true. That's another application. Usually most people score right there in the middle, and then fewer and fewer people score above that. Lesser and lesser score below, generally speaking. So a student scored 38 points on a biology test where the class average was 40 and the standard deviation was 5. Okay. He also scored 76 points on a history test where the class average was 82, standard deviation was 10. So the question is, on which test was the student's performance higher relative to his classmates? It turns out if we can get the z-score for both of these tests, what is his z-score? That tells us how many standard deviations he is away from the class average. And we'll easily be able to answer that question, which test was higher compared to his classmates. So let's look at the biology first. I'm going to cover up the history test for just a second. If we go back and reread the biology, they give us 3 numbers. They give us his score, 38. The class average was 40. The standard deviation was 5. And so if you think, well, what does that mean for our formula? His score is the score in question, so that's x equals 38. And then we've got our average and our standard deviation. Okay. Then it talks about the history test. His score was 76. The average was 82. Standard deviation was 10. So same idea there for the history. Now you think, in both cases, he scored less than the class average, right? But here it was only 2 points less. Here it was 6 points less. But we need more information than that, turns out. We need to know the spread of the data in each class, which comes from the standard deviation. So compared, how far did he go down, but compared to the standard deviation. So if we apply our formula for z to both of these, plug in our x, our mu, our sigma for each one, and get the 2 z-scores, there they are. And I invite you, be writing all of this down. I'm probably going much faster than I would be if we were in class together, since I'm not writing it and that sort of thing. But our 2 z-scores for biology, negative 0.4. For history, negative 0.6. And I told you guys, okay, once we know these numbers, we should be able to easily answer this. Which test did he score better compared to his classmates? And we're going to take the larger z-score. Well, since they're negative, the larger one is actually the negative 0.4. It was his biology test that he scored higher relative to his classmates. He's only negative 0.4. He's only 0.4 below the mean on this one. He's 0.6 below the mean over here on his history test. So again, the moral of the story, you pick the higher z-score. If these were positive, then you would still pick the higher one. They just have to be negative. That's why we picked that guy. Okay, well, I think we're going to conclude Our first video here, we're at about 15 minutes. So take a look at that. We will get to practice problem number 3 on the next video.